Hello everyone. In this tutorial, I will show you the full process of preparing a ready-made 3D car model for use in a game. We will create and configure a control script and set up the car's physics behavior. Let's get started. First, we'll create a base class using the main nodes and a basic script. Then we'll create a child of that class, add our car model and configure it. We'll be testing it on a pre-made track, create a new scene and select other node. VehicleBody3D is a class that extends rigid body and adds settings for creating a vehicle. The car will include a camera that moves along with it. We'll attach the camera to a spring arm 3D. It's perfect for this. Don't forget to disable the collision mask here, we don't need it. Now, let's add the camera itself. We'll increase the length of the arm to 5 meters. Let's save our scene in a new folder called car and name the scene vehicle. Alright, let's add our script. Now we're going to write some code and I'll explain in detail how it works. If you're not interested in the coding part, you can grab the script from the description and skip ahead. I'll name the class vehicle. Next, I'll copy 4 export variables and go through them one by one. The first variable is torque. You can think of it as engine power. The higher the value, the higher the speed. The second variable is the max RPM for the wheels, which is needed for smooth speed changes. The next 2 variables are for the wheel turning angle. I'll pass the code. In the physics process, every frame we will calculate and set the values for engine force and steering. These are built-in variables in VehicleBody3D. You can find them right here. I'll add the code. I also added new action variables in the project settings under the Input Map tab. The Dir variable represents forward or backward movement. Steer Dir is for left or right. The getActionStrength method of the input class returns a float value from 0 to 1. Thus, these 2 variables, just like the other 2, ultimately give us a value from -1 to +1. Okay, now let's assign the values to engine force and steering. Engine force is calculated quite simply. It's the direction multiplied by the torque. However, the wheels should turn smoothly. The lerp function will help us with that. The steering value will trend toward steer dir multiplied by turn amount and will never exceed it, as turn speed multiplied by delta is always less than 1. Alright, it's time to add smooth acceleration. To do this, we'll need to multiply the force by a factor. I'll add the code. First, here are 2 export variables. They will point to the drive wheel nodes from which we'll read the rotation per minute. Then I'll add the code for the RPM calculation. We read the values from the wheels and calculate the average. Now, one final thing. Apply this to calculate the engine force. I'll paste the code. Essentially, we subtract the current RPM divided by the max RPM from 1. This way, as speed increases, engine power decreases, giving us smooth acceleration and the top speed limit. Great! One more thing to add is the car slowing down when the player isn't pressing any keys. I'll add the code. Note that we've added all 3 parameters of the VehicleBody3D: engine force, steering, and brake. We're done with the VehicleBody3D setup, but the camera remains. For the camera mount, we'll use the spring arm 3D. Let's mark the node as a unique name. I've already done that, so we can easily access it from the code. Okay, I'll add an additional export variable for mouse sensitivity and the rotation code. This code will work inside the unhandled input function, where we get the event variable. We specifically need mouse movement, so we perform this check. Then we rotate the spring arm on the X and Y axis based on the relative mouse movement multiplied by our sensitivity. We'll limit the vertical movement to these values so the camera doesn't spin in circles or clip into the ground. Also, for convenience, we can keep the Y-axis rotation between 0 and 360 degrees. Though it's not mandatory, I'll also add code to capture the mouse cursor. Okay, we're done with the script. Don't forget to save. Now it's time to create our car. Click Scene, New Inherited Scene, select Vehicle and open it. Okay, we've inherited this scene. Let's rename the node to my car. I'll save this scene immediately. Now, time for the import. I'll create a folder called models and drag the model from the file explorer. Great, the model is imported. The textures were added separately. On the model file itself, I click New Inherited to get access to the mesh. Excellent. I'll need this mesh. I'll copy it with Ctrl-C. Go back and press Ctrl-V. Perfect. The mesh and textures are in order. Let's get to work. This model allows for some customization. We have several headlights here. I'll delete the extras and keep these. I like them better. Same for the exhaust pipes. I'll delete this one and keep these. For the car to work, we need VehicleWheel3D nodes. Let's configure them now. In the wheel section, the radius is 0.52. Next is the friction slip parameter, which handles sliding. I'll set it to 2.0. In the suspension section, we need to change the suspension travel to 0.25 and the stiffness. There's a tooltip explaining what that is and what values are typical. I'll set it to 25. Now I'll duplicate the wheels so we have 4 and rename them. For the front wheels in the VehicleWheel3D settings, I'll enable use traction, meaning these wheels will drive the car, and they will also steer, so we'll have a front-wheel drive car. For the 2 rear wheels, I'll decrease the friction slip to 1.9. This will allow the car to drift a bit. Okay, right now all 4 wheels are at the origin. We need to place them on our model so that the gizmo is in the center of the wheel. I'll select the front left wheel, go to Transform Position, copy it, and paste it into the wheel nodes transform. Then I need to move the mesh itself inside the wheel node and reset its position. To make it easier, you can favorite the position parameter, then copy and paste. Let's do the same for the others. Okay, I see all my wheels have moved up. Let's lower them. I'll press 3 on the keyboard and bring them down like this. Good. Yes, the circles are centered. Perfect. That's exactly how it should be. Now, I'll configure the root node. Increase the torque to 2500 and the max RPM to 900. I'll also set the car's mass in the rigid body settings to 990 kilograms. But there's one more thing to do with the mass. As you know, in a real car, the center of mass is down here, shifted lower so the car doesn't flip during turns. Go to Mass Distribution, set Center of Mass to Custom, and shift it down on the y-axis by minus 0.3 meters. One more setting. We need to select the nodes for the drive wheels. Let's pick our nodes. Okay, let's save our scene. We don't need the mesh scene anymore. Let's close it. Wait, I forgot the collision. The warning icon is telling us about it. Let's add a collision shape 3D. I'll add a shape and position it roughly like this. To stretch it evenly to the left and right, you can hold Alt while dragging. I'll duplicate this collision shape, make the shape unique, and add it here. I'll add a few more collision shapes to better match the geometry. Alright, I think I'm done with the collision shapes. Now, let's add our car to the track I prepared. Open the track scene by pressing Ctrl-Shift-O and drag our car into the scene. Let's rotate it lift it up a bit, and run the scene to see what happens. Let's hit drive. The car moves. Everything is perfect. In this video, we used 3D models from the modular racing car pack. You'll find the link to this pack in the description. If you like this video, support us with a like. Be sure to tell us in the comments if you managed to follow along and what other topics you'd like to see. Thanks everyone. See you next time.